In this video, we will cover the basics of creating a 3D model from photographs using Agisoft Metashape. This will cover adding images, assessing the image quality, masking images, aligning photographs, creating and cleaning a dense cloud, creating texturing, and finally exporting a model. Agisoft has the possibility to add a variety of different data types, including video and laser scans. In this case, we will just use images. Adding your images to Metashape is a very simple process. All you need to do is select the images you want to add from your hard drive and then drag and drop them into the main window of Metashape. You should now see the images have been added to the Photos tab at the bottom of the screen. Before we start processing them into a mesh, we will need to check the quality of the images to ensure that there will be fewer issues later on in the process. Firstly, we will go through each of the pictures, checking for blurred or unnecessary images. If we find any, we can remove them from processing by right-clicking and either choosing Remove Image or Disable Image. We can also get an idea of the image quality by right-clicking on Image and selecting Estimate Image Quality. If we then choose All Images, Metashape will assess the images for factors like blur and depth of field and give you a value. However, you should be aware that this can sometimes be problematic, where for example you have images with a lot of blurred background but an in-focus object. You can find the quality of the images by going to the Details tab in the Photos panel. Since not all of the areas of the photographs will need to be included in the model creation, it is often necessary to mask areas of photographs out. The quickest way to do this is to select all the images, right-click, Masks, Generate Masks, and then select AI. Use Replacement as the operation and apply the two selected images. This will automatically generate masks for you. You will, however, need to manually adjust the masks as the area detection is not perfect. To do this, there are three tools that you can use: a rectangle selection tool, hotkey M, a wand tool, hotkey W, and a lasso tool, hotkey L. Once you have created an area of the photograph that you want to mask, you will press Ctrl, Shift and A to apply the mask. Alternatively, if you need to remove an area, press Ctrl, Shift S to subtract. Masking photographs or objects makes it easier to align them if you're attempting to recreate the entirety of the object, for example all sides, and speeds up the processing of planar surfaces like rock art since you are removing complex geometry like vegetation from the calculation. In the following demonstration, we will use a set of photographs from a rock art documentation in Sweden. The photographs will not be masked for demonstrative purposes. Once you have imported and masked the photographs, you will need to align the photos into a sparse point cloud. A point cloud is a series of vertices, single points in 3D space, that are used to create a mesh in the following stages. To start the process, you will go to Workflow and then Align Photos. In the menu box that comes up, you will see an option for accuracy. This relates to how much the image resolution is upscaled or downscaled by the software. To keep the images at the same resolution as they were taken, set this to high. Each level of quality lower than this reduces the pixel count by half. If you need to quickly check that alignment has worked, or you do not have time to process it high, you can set the quality to lower, but be aware that this will reduce the quality of your model. Generic preselection speeds up the alignment process by point matching on a subset of images first. It should be left on. The next box should be set to estimated, as we want it to run directly from the photographs. Other options include source, which is when you have a GPS coordinates on your photographs, for example from drone surveys. Should you need to reset your alignment because you have added new photos or removed some, you will click the Reset Current Alignment box. It is greyed out here as there is no alignment currently active. Save Project after each step is a new feature that does exactly that, so it's good to turn it on. When you start processing, you will be asked to save your project. In the Advanced tab, there are a few options for key point limits, tie point limits. Key points are points that are created across an image as areas that the software determines are distinct enough to potentially line up to other images, whereas tie points are areas where the software has recognised the feature in two or more images. The default values are pretty good, but should the photos fail to align, it's possible to increase them as this adds extra points to each photo which can then be searched for. Be aware, however, that having too many key and tie points can reduce the quality of the overall mesh as it is less picky about the quality of each point. If you have masks, you can apply none, tie points or key points, and this will exclude the creation of key or tie points in the areas that you have masked, or ignore the masks entirely. Exclude stationary tie points can help remove areas of photographs that are static in multiple images. For example, you have a static camera and a moving object. However, I found this is often preferable to just mask images manually. Guided image matching increases the number of key points per image and is usually only used on cameras with extremely high resolution, as it changes the number of key points from a selected number to one that is chosen per megapixel. I tend to just leave it on. Adaptive camera model fitting tries to make adjustments based on the camera, lens and shooting methodology you took the photographs with. Again, just leave it on. Once you're ready, you can press OK and the photographs will begin to align. The next step is to use the sparse point cloud to create a denser mesh that can be used for creating DEMs and 3D meshes. By the end of this stage, your model should be quite recognisable as the object you photographed. In recent updates, Agisoft have moved more towards skipping the dense cloud creation, though it's still highly useful as a step for cleaning up meshes and testing quality before a model is built in certain workflows. Before starting the point cloud calculation, it is a good idea to resize the area that is going to be worked on. Around the sparse cloud, you'll see that there is a cube. This is the working area. Any points outside of this box will not be considered during the next calculation, so removing extraneous points will reduce calculation time and give a cleaner result. To change the size of the box, go to the icon on the bar and click the arrow next to it. You will note that there are several options for resizing, rotating and moving the area. To resize the area, click the resize icon and drag the gizmo spheres around until only your object is within the working area. When that is done, go into the workflow menu and then select Build Point Cloud. In the menu that comes up, there are a number of options. Quality refers to how much the original images will be downscaled. Ultra high refers to a 1-to-1 scaling, but will usually end in a processing time that's too long to be practical. We typically use high for smaller models and medium for very large models. We have found that the results for these work quite well. Avoid low or lowest unless you are just testing to see if your model will work. Reuse depth maps will only be available if you have previously created a point cloud or a mesh for this model. If you have and are redoing the point cloud, turn this option on as it will save you processing time. In the advanced section, you will find options for depth filtering. Depth filtering essentially removes smaller details that might be related to poor photographs. Unless you've had problems with your mesh being too noisy, like having lumps and bumps that are not supposed to be on there, then you should leave this on mild. Calculate point colors attributes colors to the points of the dense cloud. Calculate point confidence counts how many depth maps have been used to calculate each point. This is very useful as you can clean the point cloud of poor quality points using the statistic. This is demonstrated in more detail in an additional video in this course. When you're ready, press OK and the point cloud will calculate. If you want to be sure that the process is still running, click the details button on the processing window and you will see what's happening. This process can take several hours or even several days depending on how many photographs you have used. This is also one of the processes that use your GPU to calculate, so you should expect your computer to be noisy while this is running. When it's finished, you will now have a point cloud that should be recognisable as the object you photographed. If it does not come up immediately, click the point cloud tab in the menu. To build your mesh, go to Workflow, Build Model. In the menu that comes up, you can choose your source data, which can be type points, depth maps, or a point cloud. Point cloud will create a very high resolution model from your previous step, whereas depth maps will use the calculated depths from the photograph to create a model. In this example, we'll use point cloud, but it is also not a problem to use depth maps if you wish to skip point cloud generation. There are two options for surface type. The first is height field and is suited for flat surfaces and terrains only. If you try to make a non-flat model with this mode, you'll end up with a mess as it will only construct it properly from one direction. The other mode is arbitrary 3D. With this mode, the software can render from all sides, for example for an ordinary 3D model. The downside is it takes a lot longer to process. Face count determines the final size of the model in terms of how many polygons it will have. There are several presets that you can choose from depending on what you intend to do with your model. We usually use high. Interpolation fills holes in your mesh. If you had a very good photograph set, you can select disabled and it will create a solid mesh for you. But if you have any problems, you can leave enabled on. Be aware that this may generate new geometry that might be challenged to get rid of and may not fully represent the original. Leave calculate vertex colors off, press OK and wait for the dense cloud to become a mesh. When the processing is finished, you may need to click the View Mesh button at the top of the screen to see your model. If your model has loose parts around the edges, you can clean it up using the Lasso tool in the top menu. Select the Lasso tool and then drag around the areas you want to remove to select them, and then press Delete. Alternatively, and more simply, you can go to Model, Gradual Selection, Connected Component Size, and then move the slider up to 99%. Provided the largest part of the geometry is your mesh, it should select everything but that, meaning you can delete it. If you do skip cleaning your mesh, the next steps may fail as the software will try to calculate each loose part separately. Now that you have a mesh, you will need to create a texture for it. Agisoft uses the photographs to create a texture based on the location of the photographs and where they are located on the model. It then creates a square image that is UV mapped to the mesh, a process that will be covered later in the course. Go to Workflow, Build Texture, and in the options box that opens you will only need to change a couple of things. You want your texture type to be diffuse, which is essentially colours, and you want your mapping mode to be generic, as this will automatically split up your model for you. Your texture size should be 8192, but you can also change this to lower if it's taking too long. Press OK and the texture will be generated. You can now view the model with a texture by going to the View Model menu option and selecting Model Textured. You should now see a fully textured 3D model. To export the model, go to File, Export Model, and then select the location. Give it a name and add the suffix _mesh. There are multiple options for which file format to save as. The most common and simplest to work with and share is OBJ or PLY. You can also export the 3D model as a PDF. Click Save and you will have successfully created and exported your model. In this video, we've covered the steps necessary to create a textures model which is ready to be exported.